A state-of-the-art tank, armed, steel-clad, and on the move. The pinnacle of mobility of a 4,000-year race to bring speed, protection, and firepower to the battlefield. The quest for mobility has produced many shockwaves, from the ancient chariot to heavily armed cavalry to the mighty battle tank. Each step forward has caused advantage to shift and armies to adapt.
This is the age of the knight. He is virtually invincible.
Always it has been the hunt for the perfect formula of armor, agility, and weapons. The results have been creative and intimidating.
Nothing you shoot at them will stop them, and in your mind, it's you they're coming for.
And when they come with force.
It's the Holocaust on the tank battlefield.
The ultimate goal, the creation of the perfect armed fighting machine. In ground warfare, mobile units are at the heart of the fighting force. What they bring to the battlefield is the ability to project power over distance and cover ground faster than infantry. Today, the American Abrams M1A2 tank reigns supreme. It is one of the largest, most complex ground war machines ever built, crushing firepower and formidable armor put it at the apex of tank evolution.
There are three primary factors that influence tank design. They are how big is the gun, how well protected are they, and how mobile are they?
The way these questions are answered depends on the goal of the designer. The Abrams' big gun and thick armor come at a price to its speed and maneuverability. These trade-offs, so integral to the decision-making process today, have been influencing weapons builders for millennia, all the way back to the age of the chariot. In 1457 BC, Megiddo, in the Middle East. Two great armies clashed in one of history's earliest recorded chariot battles. Egyptian mobile forces led by Pharaoh Thutmose III attacked a coalition of Canaanite rebels. With speed and ferocity, they won the battle and captured close to 1,000 enemy chariots. The Egyptian chariots were cutting edge for their time, an improvement on earlier designs from other civilizations. They exhibited an effective blend of features: a horse for propulsion, 6-spoked wheels for strength and speed, and a bow for firepower. Earlier pre-Egyptian chariots had been heavier and more cumbersome, like the Sumerian battle wagon with 4 solid disc wheels. But the Egyptian archers wanted a more nimble fighting machine, a stable but maneuverable platform from which they could aim and shoot.
The Egyptian chariot was a fighting vehicle, and as in all fighting vehicles, you want to make them ride smoothly so you have accuracy when firing your missiles. One of the ways the Egyptians achieved a smooth riding firing platform was through the design and construction of the wheels. These included eventually 6 spokes, rims wrapped in shrunken hide, which formed a tire. As well, the fighting deck that the warrior and the driver stood on had a springy feel that absorbed a lot of the shock.
Many of the Egyptian design features can still be seen on today's chariots, or at least their modern-day racing equivalents. These harness racing carts, known as sulkies, are built for speed and mobility. Though it looks simple, the sulky is expertly designed. Every detail of the cart is carefully constructed to maximize speed around the racetrack. It weighs as little as 58 pounds, and its frame tube is elliptically shaped, like an airplane wing, to minimize drag. Low weight is essential for speed, and remarkably, the Egyptian chariot was not much heavier than the modern sulky. It weighed about 80 pounds. The Egyptians sacrificed armor to keep the weight down. But that meant the two-man crew, driver and archer, were left unprotected.
That's not because they didn't want to protect the individual inside. It's because they felt they didn't need to. Because any chariot was supposed to fight away from the army. They were supposed to be able to pour archery fire on somewhere from a distance.
That way they could be effective, but stay out of harm's way. The Egyptians fine-tuned their vehicle to meet the desired specs. They set the axle at the very rear of the platform, maximizing the chariot's ability to quickly change direction during battle.
These chariots had to be able to turn on a dime, stop on a dime, where other chariots are turning, spinning, and wheeling.
But the rapid changes in direction increased the likelihood of a flip. To reduce that risk, Egyptian engineers widened the wheelbase. With almost 6 feet between the two wheels, the chariot could take tight turns and still remain upright. The design worked well for the Egyptians. It gave them an effective weapon for the style of fighting they preferred and the terrain on which they fought. But not all armies opted for fast and maneuverable. As battle tactics evolved, other commanders found new uses for chariots in war. This titanic machine rolled across the Middle East in the 7th century BC. It belonged to the Assyrians and carried 4 heavily armed and armored warriors. It was built to plow through light infantry.
It was meant to ride directly into the infantry force, to make the driver, to make the riders all part of a military unit to attack.
The chariot proved its worth for thousands of years, but it did have limitations. It failed on rough or swampy ground, and it was expensive to build and maintain. By Roman times, it had been relegated to ceremonial use and racing. Ironically, the chariot was ultimately usurped by one of its own key components.
What kills off the chariot is the horse. Now that seems very strange, but horseback riding will eventually mean that the chariot is no longer needed on the battlefield.
Selective breeding turned the lightweight draft animal into a powerful beast that could carry a man into battle. Saddles soon followed, but it would take hundreds of years before another innovation in China would transform the horse into a true weapon of war. It was the solid stirrup, and it fused horse and rider into a single fighting unit. Over the next centuries, it slowly made its way across Asia to the battlefields of Europe. There, it turned heavily armed cavalrymen into dominant medieval fighters. In 1429, Patay, in northern France. A crucial battle in the vicious 100 Years' War between the English and the French. At Patay, the English infantry was unprepared for an attack of 1,500 heavily armed French horsemen. The cavalry swept through the English lines. It was a swift and total defeat. The foot soldiers were overwhelmed by the riders and their steeds.
This is the age of the knight. The man who rides on his horse, who is armored, who carries a lance, and uses cavalry tactics, he is virtually invincible.
Invincible in large part because of the leverage and balance his iron stirrups gave him in the saddle. A simple contest demonstrates the advantage. Two horsemen, one equipped with stirrups and one without, prepare to engage in a duel. The fighter in green uses his stirrups to generate force as he strikes. The horseman in brown has less leverage. His blows are weaker and he is easily thrown. Between the forged metal stirrup, the powerful horse, and the heavy armor, the mounted warrior cast an imposing shadow. The medieval heavy cavalrymen were battle systems unto themselves. They dominated European conflicts for 500 years. Tactically, these horse-borne warriors were often deployed like battering rams, bearing down on their enemies in a single line, sweeping men aside with the sheer force of their charge. Knights were the elite of the heavy cavalry. Their status and position were superior to that of regular soldiers. But knights had to buy their own armor and horses, so in effect, they became mercenaries for kings and dukes who paid them with gifts of land. The knights fought for their nobles at home and abroad. They had a distinct culture and a powerful influence on medieval conflict. By the middle of the 12th century, they were found across Western Europe. One of the knights' training methods, and also an exciting sport in medieval society, was the joust. Once again, it was the stirrup that provided the stability and balance.
He could carry bigger equipment. The lance suddenly went from a stick to almost a tree that he could carry, and this was knocking people out of the way.
Predictably, bigger weapons triggered better defense. By the 16th century, every warrior who could afford it was encased in heavy plate armor. Even the horses were protected. But plate metal is heavy, so just like the Assyrians with their chariots, knights sacrificed some mobility in favor of protection and momentum. Between the stirrup, the armor, and the lance, an approaching knight was difficult to deflect.
A rider can now put the lance under his arm and carry the impetus of the horse and the rider into a blow into an opponent.
Maximizing the potential of horse, rider, and weapons, the knight was the heavy fighting vehicle of the Middle Ages.
The man on his horse, a knight, is absolutely frightening. He was a mobile tank.
And an icon of cavalry armies that would persist for centuries as the apex of mobility in battle. Until the arrival of next great advance. 1914, World War I, Northwestern Europe. Two armies stagnated across a line of defensive trenches more than 500 miles long. Out of this massive deadlock, a revolutionary new weapon emerged, one that would change warfare forever. There in the trenches, with both sides trading fire and gaining little advantage, the need was obvious.
The question is, what kind of machine will enable you to break that trench stalemate?
The first solution came from Winston Churchill, Britain's first Lord of the Admiralty and a lover of new technology. Churchill had been captivated by armored cars, which combined mobility and protection.
Fast motor cars, and it was getting loads of publicity, all things Churchill lived for. So he backed the production of bigger and better armored cars.
The vehicles were successful against German cavalry in the early months of the war when the fighting was mobile. But they struggled in the mud and craters of the Western Front. Something with more traction was needed.
Trench stalemate brings about one of those light bulb moments in history.
The light bulb? A piece of American farm equipment that used tracks instead of wheels. What worked on the farm could work on the front. So Britain applied the concept to the world's first tank, Little Willie. The earliest prototype was a primitive metal box riding on imported American tracks. The British hoped the tracks would keep Little Willie from getting bogged down in the mud. But early tests were disappointing. Little Willie's nose stuck out in front, so if it fell into a trench, it couldn't climb out. The tank went back to the drawing board. And so, Big Willie was created, with a revolutionary new design. Its tracks went beyond the front of the body and were high enough to grip and climb over most obstacles it encountered.
The secret of this design is the way the tracks wrap all the way around the body of the tank. The reason for this is that the tanks are expected to cross wide trenches, 9 feet wide in some places, and rough ground.
Big Willie proved it was up to the task. Its crushing power was clear, and it was quickly sent to the front. The British thought they had an answer to the German trenches. In September 1916, Britain's Revolutionary War machine was unleashed on an unsuspecting enemy.
You've got to imagine a type of machine that nobody had ever seen before. And I don't just mean the Germans, and most of the British soldiers on the Somme had never seen anything like this. And they start moving in the pre-dawn mist when you can hardly see your hand in front of your face. It appears to slither along the ground. It's quite bizarre the way it moves.
So far as the Germans were concerned, they called these machines the Devil, and the cry soon went up along the trenches, "The Devil is coming."
Nothing you shoot at them will stop them, and in your mind, it's you they're coming for.
But once the Germans got over their initial shock, they realized Big Willie's bark was worse than its bite. The men inside the tank were vulnerable to counterattack.
Well, I'm in, and there's nowhere to put my hands because I'm between the transmission and the engine, and all that's hot, and I'm already feeling claustrophobic. This is the engine, a mass of red-hot moving parts. You can imagine the heat that that generates, and every crew member is only 2 or 3 feet away from it. The only way to communicate was with one of these. Of course, the crew can't really see what is going on, and they can't really derive the comfort from looking at each other because all they see is an outline in the dark. Their face is covered by one of these chainmail masks, which is some protection against the metal splinters that flake off the side of the tank as soon as it's struck by explosive.
The most difficult thing you have to worry about is plunging artillery fire, because artillery fire can kill a World War I tank. It's only moving 3 miles an hour. It's a big target.
It was only when they started to open up derelict tanks and discovered only the feet and legs of burnt crew members remaining because the upper part of the torso had completely been incinerated by the furnace, did it dawn on these people that they were part of a new type of warfare that nobody had ever experienced before.
These slow-moving monsters were futuristic in design and shocking to see, but they were not the answer to the Allies' prayers. On the Somme, many got stuck in shell craters or were destroyed by artillery. Only a third even made it to the German lines. Big Willie was designed for one specific goal: to break through German trenches and lead the Allied soldiers forward. But in the end, its novel design was unable to stand up to the rigors of war. It was too slow, had mechanical problems, and was not used as effectively as it could have been. But the tank would eventually come into its own. 20 years later, in World War II, it would establish itself as a critical weapon of war. 1940, Northwestern Europe. Hitler's Panzer tank divisions sliced through Belgium and France. Overpowering Allied defenses, they reached the English Channel in 10 days. Despite the failures of Big Willie, Germany had recognized the tank's potential and built up an impressive tank army. Ironically, one of their sources of inspiration was a British officer.
Major J.F.C. Fuller, the British Army, is visionary when it comes to the use of the tank.
After World War I, Fuller had rejected the original concept of tanks leading infantry into battle. He foresaw tank units that could be used in numbers and at high speed. Fuller's vision was radical, and the enemy was paying attention.
Fuller, ironically, can't sell the idea in Britain. He can't sell the idea in America, but the Germans are reading him.
One German in particular, General Heinz Guderian, the father of German tank warfare. Guderian turned Fuller's ideas into reality: high-speed armored divisions able to win battles on their own. The Panzers were unleashed on Belgium and France with great success. The early models emphasized speed over armor and firepower. They were supported by aircraft and by infantry carriers and artillery that were also on tracks. Importantly, the vehicles could also receive and send messages.
There's one thing that you might not think about, but it's absolutely essential. It's the ability of one tank to communicate with another, so it's the radio.
In 1940, most Allied tanks had receivers that could only handle incoming signals. But Guderian's tanks were equipped with two-way radios, so commanders could coordinate their forces during battle. Throughout 1940, the German panzer units had great success outmaneuvering and outfighting heavier Allied armor. But then, on the Eastern Front in June 1941, the tables began to turn. The Soviets rolled out a new tank that put the Panzer to shame. The Soviet tank had its origins in the 1920s, on the other side of the world. One of its primary design elements came from American inventor J. Walter Christie. Christie was a one-time race driver with a passion for speed. He created a futuristic tank that could pierce enemy lines, soar over trenches, and cruise on tracks at over 42 miles per hour. The secret was in Christie's suspension, which was far less rigid than previous designs. They were made to crawl, his to fly. Christie invented a truly innovative system.
The secret of it, ever so simple, large diameter wheels, like these, and each wheel on a separate swinging arm pressing against a big spring.
The swing arms were shock absorbers, allowing the track to move up and down on rough terrain. Christie offered his tank to the Americans, but but they had a different philosophy on tanks and rejected it. So the Mercurial Christie sought out other buyers and sold his suspension to the Russians. They used it to create the legendary T-34. This was the tank that would take on the German Panzers in 1941. A young Leningrad engineer, Mikhail Kushkin, was put in charge of the T-34 project in the Ukraine. Kushkin's inspired idea, which exemplified a more general Russian military philosophy, was to design a tank that was basic but reliable, a workhorse on the battlefield. To prove its dependability, he drove 2 prototypes more than 400 miles to Moscow for his Red Army superiors to inspect. The T-34 won their approval, but Kushkin's design made no concessions to crew comfort, and his vehicles proved hardier than he.
Koshkin drove this tank throughout the winter. The conditions were so bad and the distance so great that he developed pneumonia and subsequently died.
But his death did little to slow the T-34 down. It quickly went into full production, and on the Eastern Front, its pace and firepower overwhelmed the German panzers. The T-34s also had another critical design feature that gave them an advantage.
For the first time, it incorporated sloping armour, so that incoming fire can ricochet off the armour.
Sloped armor was a groundbreaking concept. The shells ricochet instead of piercing, because the effective thickness of the armor gets greater as its slope increases. Earlier tanks were designed like boxes on tracks, making enemy shells more likely to penetrate. But sloped armor gives the tank superior defense. It's a simple but effective concept. When an incoming shell meets a perpendicular armor surface, it goes straight through and probably kills the crew. If the armor plate is angled at 30 degrees, the shell might bury itself in the armor, but it doesn't go through. But if a shell strikes armor plate angled at 60 degrees, it bounces off, leaving the tank and crew unharmed.
The T-34 is probably the finest example of the use of sloped armour. Here at the front, this very sharp nose. And they achieved this because everything that makes the tank go, and that's the engine, the gearbox, the steering mechanism, it's all at the back.
Sloped armor is now a permanent feature on most modern tanks. The nose of the Abrams M1A2 is almost horizontal when viewed from the front. A British Cromwell tank from World War II, on the other hand, has a far more vertical nose. The American Abrams protects its crew, but is hardly a defensive weapon. It can also overpower the enemy with its 120mm gun and thermal sight. In Operation Desert Storm, it was able to engage Iraqi tanks from outside the effective range of their weapons.
We like fighting from far. We can hit from far. No questions asked. They won't know they got hit till they got hit and they're on fire.
The Abrams can also fire with great accuracy at speed. That capability depends on a platform that remains stable at all times. The same specification required by the ancient Egyptians for their chariots. The technology needed for the weapon's stability was perfected late in the 20th century. Gun stabilizers use gyroscopes to keep the weapon locked on target, regardless of the tank's movement over the ground.
Any type of terrain you can fire on. Doesn't matter how the tank is sitting. The hull can be sitting a certain way, the bottom part of the tank can be sitting a certain way, but the gun is still going to be leveled out, ready to shoot.
The Abrams uses superior range to outgun opposing tanks. It's a deadly tactic. In World War II, it was also Germany's belated but effective response to the Soviet T-34. The Germans countered the T-34 with the Tiger, a heavy tank with a long, highly accurate gun. The Tiger had a bloody impact on the battlefield. British tank officer Peter Gudgeon witnessed its power firsthand. This is the actual Tiger that almost killed him in the Battle for Tunis in 1943. He and his men engaged a group of German tanks dug in at the top of a hill.
First we knew about it was when the leading tank on my right blew up in a massive explosion. The commander and his wireless operator were blown out of the top of the turret. The tank was ablaze, an inferno. The next thing I felt was a shot passing right down my tank, just missing my right leg. I felt the draft of it on my right leg. And it crashed through into the engine and set us on fire.
Gudgeon expected more shots, but he and his men got lucky. A shot from another British tank struck the Tiger in the turret, disabling it. The German crew bailed out and fled.
Hit it anywhere else than where it did, probably wouldn't have made any difference. One amazingly lucky hit.
It wasn't long before the sophisticated firepower of the Tiger came up against the powerful T-34. They met in one of the biggest tank battles of all time. The outcome was a referendum on military capacity and on technological philosophy. 1943, Kursk, Western Russia. Nearby, in the village of Prokhorovka, one of history's most ferocious tank confrontations began. 450 German and 800 Russian tanks amassed near the top of a hill.
You are face to face in this incredible encounter. It's almost like hand-to-hand combat with tanks.
Ahead would have been hundreds of German tanks, and every single crewman must have felt they were lining up on him personally.
You don't have time to think. You fire, you shoot, you ram.
The feeling of vulnerability is completely accentuated by this lack of vision. All I can see is the next slope ahead and very little else. They must have felt dreadfully vulnerable.
The losses are phenomenal. You have to imagine men bailing out of tanks that are on fire, and when you bail out, you're going to get shot.
The casualties on both sides were terrible.
It's the Holocaust on the tank battlefield, because the next day there are these hundreds of burning hulks.
Though the numbers are disputed, it's estimated that close to 500 tanks were destroyed that day. And that was just one engagement in the larger battle for Kursk, which ultimately involved more than 6,000 tanks. After 7 weeks of fierce fighting, the Soviets were finally able to stop the German offensive. The Soviets suffered far greater personnel and equipment losses than the Germans, but in the long run, they were better able to absorb them, in part because of their low-tech approach to tank engineering.
But if there's one thing that characterizes all these Russian tanks, it's the crude finish, and it's very noticeable here on the T-34's turret. You can see cast markings, weld markings. Now, if you compare the rough finish of this tank with the German Panther over there, the contrast is fantastic. It's as if those tanks were finished off in the Mercedes-Benz body shop. It's a beautifully made machine.
Though lighter and cheaper than the Tiger, the Panther was a typical example of complex German engineering. But such precision came at the expense of manufacturing capacity. Fewer than 1,400 Tigers and only 6,000 Panthers were ever finished. The Russians, on the other hand, could crank out T-34s. Mikhail Kushkin's simple, reliable design allowed them to mass-produce more than 57,000 and overcome the Germans with sheer force of numbers. As the war progressed and Germany was forced from offense to defense, the Army reassessed its need for fast tanks to conquer enemy territory. Now trying to defend the fatherland, they sacrificed speed for better protection. The result was the Tiger II, or King Tiger. With double the frontal armor of its predecessor, this was the heaviest tank used in World War II. It didn't prevent the German defeat, but it was another example of the mission-specific trade-offs between speed, armor, and firepower. With the changing requirements, shifting fronts, and huge armies, World War II drove rapid advances in tank design, and it saw commanders developing new tactics to take advantage of these powerful, mobile weapons. Guns got bigger, armor got thicker, and killing capacity grew. By the close of the war, J. Walter Christie's vision of an armored racing vehicle had evolved into an all-round fighting machine that commanded the battlefield. A machine that would be effective for decades, until tanks built for big set-piece battles found themselves up against a new, deadly, and far more flexible weapon. A weapon that prompted some to wonder whether the big battle tank, like the Chariot long before it, would become obsolete. (1973), a surprise attack on Israel by Egypt and Syria ignited the Yom Kippur War. Israel's tank forces, which had previously seemed invincible, suffered devastating losses. For 40 years, the most potent anti-tank weapon on the battlefield had been another tank. But in this war, Egyptian soldiers had another effective option.
There was an introduction of something that changed the equation on the battlefield, and that was this light, portable anti-tank weapon.
The Israeli tanks were being attacked by missiles that could be carried in suitcases and by rocket-propelled grenades. Anti-tank explosives had been around since World War II, but the missiles were a major improvement. A portable guided delivery system with a deadly warhead. Known as shaped charges, the warheads were designed to cut through even the thickest tank armor.
This is a shaped charge. The top part here is filled with explosive. This is designed so that when the explosion travels down here, this copper actually turns to liquid and is concentrated on a point down here. And that allows the liquid metal to actually puncture straight through the target.
It will completely carve up the crew, or it will set off ammunition fires, which in turn, of course, will produce internal explosions, which will completely finish them.
But of course, as soon as engineers realized what they were up against, they began searching for the next protective counterpunch to defend against it. (1969). German armor scientist Manfred Held made a surprising discovery while conducting research in the Middle East. Held was testing shaped charge warheads on the wrecks of battle-damaged tanks.
I was alone there. I was a project leader. I made my own pictures from every test.
Held detonated his shaped charges on the tank's turrets, fully expecting them to perforate the armor and destroy the tanks. But when he reviewed his footage, he noticed much bigger explosions than he had anticipated. Upon investigation, he discovered that the shaped charges had set off live ammunition still sitting in the turret. He realized that the secondary explosion had neutralized the effect of the shaped charges.
So the stronger reaction have reduced the penetration capability.
By accident, Held had discovered a new way to protect a tank: explosive reactive armor. Like many modern tanks, the Israeli Blazer features the new protection. Its most vulnerable points, the front arc and turret, are fitted with close to 40 reactive plates. If a plate is hit, it explodes, countering the shaped charge and leaving the tank unharmed. A demonstration reveals how it works. Two towers of steel stand in for the armor of a tank. Each will take the brunt of a shaped charge attack. A charge is placed on top of each tower. There will be two explosions, one with explosive reactive protection and one without. The one with gets a sheet of plastic explosive placed at an angle between the shaped charge and the top steel block. This simulates the position of the plate on a tank.
When the shaped charge is fired, it will detonate the sheet of plastic explosive and hopefully disrupt the blast. Then we can compare the number of steel plates penetrated with the protection of explosive reactive armor and without. Firing in 3, 2, 1, firing! Firing! There was a huge release of energy in both those two explosions. This first stack, we didn't have anything between the shaped charge and the top plate.
The shaped charge left a neat entry hole, and the blast penetrated almost 6 plates. That's 6 inches of steel.
It's actually gone almost all the way through it. If we compare that to the stack that was protected by our simulated explosive reactive armor, the entry on the top plate is a lot messier. A lot of this seems to have been disrupted.
But the shaped charge has only gone through 3.5 plates. The explosive reactive armor has reduced the impact by almost half.
So had this been an attack on a tank, I think the protection offered by the explosive reactive armor could well have saved the crew's lives.
Once again, armor had caught up with the innovative weapons, intent on destroying it. Israel was the first to adopt the explosive reactive armor. It is just one of many safety features designed into Israel's main battle tank, the Merkava. After losing 2,500 men, most of them tank soldiers in the Yom Kippur War, the Israelis placed a high premium on tank crew protection. For such a small country with so few soldiers, the loss of highly skilled tank crews is a political, economic, and military tragedy. Soldiers are extremely precious, so their safety is the #1 priority. Firepower and mobility come second and third. Unlike all other main battle tanks, the Merkava's engine is in front, which puts an extra barrier between the crew and incoming fire. The tank's shape, streamlined and flat, makes it difficult to hit. Even the turret is designed to present a low-profile target.
The turret is basically on the top. It's very narrow, so it will be very, very hard to hit. As you can see, it's shaped as an arrow to the front.
If the tank is hit, soldiers have an increased chance of survival because ammunition and flammable liquids are kept separate from the crew area. and the crew can make a rapid exit through a rear-facing escape hatch.
What happens, I give my crew just a command. They all get out of their cells and just come out of the tank from this rear hatch. We can open it from inside. It just opens on the top and on the bottom. The whole crew gets out and we go to a safer spot.
The Israeli Merkava represents the pinnacle of crew safety, a conscious decision by the Israeli army to put protection first. But it is not necessarily the best all-round tank. Other countries, like the US, opt for a different balance of firepower, speed, and protection. The American Abrams has that balance. Early versions of the tank played a critical role in ground war offensives during both Gulf Wars. The latest Abrams, the M1A2, is even more intimidating, with improved armaments, protection, and electronics. Its massive 120mm gun has a laser rangefinder, and it's tough, protected by multiple layers of steel and ceramics and an option of reactive armor.
Abrams tank is the most powerful battle tank in the world right now. There is no tank that can match an Abrams in open battle.
At close to 70 tons, the Abrams is one of the largest tanks ever to do battle. Inevitably, such size comes with consequences. It guzzles fuel at nearly 2 gallons per mile and is heavy to transport. But on open battlefields, its ability to project power far outweighs these kinds of logistical problems.
If you're projecting the possibility of a war with, say, an enemy like North Korea, that will be a conventional war. And you'll need an Abrams. You've got to have an Abrams.
But the Abrams isn't ideal for all conflicts, particularly the asymmetric battles of today, which are often fought in urban environments and against highly mobile insurgents.
Definitely the place that is the most dangerous for using a tank would be an urban environment. The most restrictions, the most opportunity to get behind you or over you to attack you.
Because of these limitations, weapons designers have had to produce less powerful but more flexible machines. The Stryker, used in Iraq since 2003, is an armored personnel carrier with 8 wheels instead of tracks. It's used as a battlefield taxi, delivering troops with speed and some protection. The Stryker's firepower and armor are inferior to that of the Abrams, and in Iraq it proved vulnerable to roadside bombs. But it is 3 times lighter than a battle tank, so it can easily be airlifted to trouble spots. And in urban environments, it is far more mobile.
A Stryker can go down streets that an Abrams tank is too large to get through, because the tank is so big and so powerful.
The Stryker is the latest in a tradition of lighter vehicles that have evolved alongside tanks in response to battlefield demands. Most recognizable is the Jeep, America's transport backbone during World War II. More recently, the Humvee has entered the battlefield as a hybrid troop carrier, ambulance, and automatic weapons platform. Equipped with a roof-mounted .50 caliber machine gun, it has found an important role in modern combat. Strykers and Humvees use their superior mobility to evade enemy guns. But because those guns are always becoming more potent, the most effective way to avoid being hit is to avoid being detected in the first place.
New rule of warfare is, if you can see it, you can hit it. If you can hit it, you can kill it. Doesn't matter what it is. So that makes the importance of not being seen much greater than it ever has been in the past.
And so designers of future weapons are investigating a new dimension of tank design: invisibility. Cutting-edge technologies from camouflage to stealth are being researched and tested. These Leopard 2 tanks from the Armored Battalion of the Danish Army are on their way to Helmand Province in Afghanistan. But before they leave, they are given a new skin to hide their presence from the enemy. Anti-tank weapons use thermal targeting to zero in on a tank's telltale heat signature. This camouflage helps disguise it. The skin combines layers of high-tech materials that deflect enemy radar and reduce the tank's thermal footprint. It's far from perfect, but the difference is easy to see. The front tank, without the new camouflage, shows up white-hot on the thermal imager. The second tank, which does have the new skin, is more difficult to see.
Most of the tank will not be visible on a thermal imager, so you will be able to get up and get the first shot before they even recognize you.
Though still in its infancy, some variation of camouflage technology may be the next step forward that gives its user an advantage on the battlefield. A battlefield that is always changing, where tanks must adapt to survive. Since before the Pharaohs, the wheels of war have turned beneath the most destructive fighting machines the world has ever seen. And thanks to technology's dynamic advance, the mobile forces of the world's armies have evolved to strike out at high speed and with great force. Over thousands of years, these machines have helped drive the changing tactics of battle, both protecting and killing with ever greater efficiency. The future will be no different, shaped by the awesome combination of speed, armor, and firepower.